So today we're going to switch over to the transformation called reflection. Reflection, sometimes you may have heard referred to in middle school or something like that as a flip, but it's actually called a reflection. We're going to use that. One thing that's interesting about a reflection is whenever we do a reflection, we start with a pre-image, like we have with translations, an original point, and we go to an image. So like P is my pre-image, and P prime might be my image. And this time we're going to reflect, whenever we reflect over a line. With translation, we move things according to a vector. Whenever we reflect over a line. And the interesting thing is, when I reflect over a line, the segment that connects the pre-image to the image, P to P primed, is always perpendicular to the line of reflection. If a point happens to be on the line of reflection, it doesn't go anywhere. It stays right where it's at. So PP primed is always right there. In fact, line M, like I said, not only is perpendicular, it's a perpendicular bisector of the segment PP primed. So P to the line of reflection, that distance equals P primed to the line of reflection. Pretty clear. All right, that's our big idea. So how do we do reflection? Well, one of the easiest ways to do reflection is simply to do it in the coordinate plane with a picture. Whenever we reflect, we have to reflect in a line. Now, often we reflect in an axis. We'll get to that in a minute, but sometimes we reflect in other lines. In this case, we're going to reflect in the line x equals 3. Now, this actually kind of sometimes represents a problem for people. Where is x equal 3? Where is that line? Well, we have to think for a second. This is our x-axis, right? And x equals 0 here. Here's 1, 2, 3, 4. On what line does x equal 3? Well, that is on this line right here, right? So that's going to be my line of reflection in this case. X equals 3 right there. That's my line of reflection. So every point is going to reflect in that line. Now, in this case, the line happens to go right through the object I'm reflecting. Not a problem. When we reflect something, we always reflect one point at a time. In fact, this is going to be kind of a key for everything that we do from this point on. Whenever we do any transformation, we generally want to transform individual points, one at a time. So I'm just going to start with A. Here's point A right there, okay? I want to reflect point A in this line. Well, point A is 2 units over to that line. So I'm going to go 2 units to the other side, and there's going to be my image of A primed. Point B is right here. That's 2 units over to the line. So I'm going to reflect over 2, and there's B primed. Point C is 1 unit to the left of the line, so I'm going to go 1 unit to the right, and there's C primed. And we're going to connect the dots when we're done. And there's my image. Okay? So again, reflecting in the coordinate plane when I have a picture is actually pretty easy so long as I do it one point at a time and can locate the line of reflection. Let's do another one. Here's the same picture. This time we're going to reflect in the line y equals -1. Well, x equals 3 was on the x-axis 3 units over. So y equals -1 has to be on the y-axis 1 unit down. Oh. There's my line of reflection. We want to mark that in. And now we just reflect again one point at a time. A right here is 1, 2, 3, 4 units up from the line of reflection. So we go 1, 2, 3, 4 units down, and there's marking A primed. C is 2 units up from the line of reflection, so we go 2 units down, and there's my C primed. B is 1, 2, 3 units up from the line of reflection, so I'm going to go 3 units down from the line of reflection. Okay, and there's my B primed. And I've reflected my object very nicely. Not a problem at all. Reflecting a diagonal line is a little more challenging because you have to reflect along diagonals. Let's say I have segment FG with F is at -1, 2. So let's mark that in first. There's F. And G is at 1, 2. Positive 1, 2. Okay. Very simple little segment. I want to reflect in this diagonal line. Well, in order to reflect in a diagonal, I have to work on the perpendicular diagonal. Okay? So I'm going to reflect this across the diagonal that way. Now, it was half a box on the diagonal from G to their line of reflection. So we get half a box on the other side. And I find G primed. For F, again, we're going to have to reflect on the diagonal, the opposite diagonal, which is going this way across my boxes. And it's 1.5 boxes on the diagonal to the mirror. So we go 1.5 boxes the other way. And we find our F primed. And there's our reflection. So again, this is really, like I said, a very visual process. It's something we do with graph paper. Make sure you have plenty of graph paper when you're doing this because drawing is important. It also helps to have some sort of a straight edge so you can get nice straight lines. If you start getting all sorts of wavy, weird lines, it can be really tough to work with. So having something to use as a straight edge can be really useful. There are rules for special reflections in the X and the Y axis. We're not going to spend time memorizing them because those are pretty easy reflections. So don't worry about memorizing that. The vertices of JKL are given, and graph JKL and its image after reflection in the x-axis. All right, no problem. So the x-axis is this one. This is the y-axis. Since the x-axis is my mirror, that's really nice and easy. So L primed is right there. K primed was, what, 1, 2, 3, 4 up. So 1, 2, 4 down. And J primed is 3 up, so 3 down. Whoops, I miscounted. There's J primed. My bad. Okay. And when I look at the coordinates of that, J primed was now at 1, -3. K primed was at 3 negative, or at 4 -4. And L primed was at 3 -1. So the x coordinates did not change, but the y coordinates just changed sign when I reflected in the x-axis. Well, that's kind of nifty. Okay. Reflection in the line y equals -x. Okay, y equals x is the 45-degree diagonal up to the right. Y equals -x is the 45-degree diagonal coming down this way. Okay, that's the line y equals -x. So if I reflect in that, again, we've kind of done this before. When we're reflecting a diagonal, we go on the opposite diagonal. I'm 2 boxes over, so I'm going to go 2 boxes over. So that's going to have to be my L primed. Okay. J is exactly 2 boxes over, so 2 boxes over on the diagonal there. There's my J primed. Again, we're reflecting 1 point at a time. And K is 1, 2, 3, 4 boxes over on the diagonal. So 1, 2, 3, 4 boxes over on this diagonal. And we found our K primed. And there's our reflection. And from there, we could read off the coordinates. Reflection is a rigid motion. It preserves all shape. We get an exact copy of my original figure, just flipped over the line of reflection. Similar with reflection is what's called symmetry and dealing with lines of symmetry. Again, this is an old topic you've seen a lot of in middle school, so just a very quick review here. A line of symmetry means if I reflect over that line, I get exactly the same image. Okay, C is really easy here because C only has one line of symmetry. If I reflect over that line, I get exactly the same figure back. A is a little bit more interesting because I have a couple lines of symmetry. I have one that goes here and one that goes approximately here. So I get 2 lines of symmetry here for reflection. B is really interesting. Because B is a regular polygon, I get lots of lines of symmetry. I get one here. I get one here. I get one here. I get one here. One here. And one there. 6 lines of symmetry. Because the 6-sided polygon, that's regular. Means all sides the same, all angles the same. So finding lines of symmetry, yeah, we're going to deal with it a little bit. I'm not spending a lot of time talking about it because, again, this is a topic you hit really hard in middle school. I don't think it's something we need to spend a lot of time on here. What I do want to spend time getting to is the idea of matrices and using matrices for reflection. We're only going to worry about reflecting in the x-axis and the y-axis when it comes to matrices. So if we're going to do, let's say we have a polygon that I need to reflect in the x-axis or the y-axis, and I don't have access to graph paper. Well, in these 2 cases, we can use reflection matrices. Now, do not worry about memorizing these reflection matrices. They will always be given to you. But when we do reflections with matrices, okay, we always multiply the reflection matrix times the coordinate matrix. The reflection matrix must go first. The polygon coordinate matrix goes second. Why? Because usually a dimension thing, if you go back to 40B, when we talked about multiplying matrices, we talked row times column. Remember that when we're multiplying, okay, rows times columns, row 1 times column 1, row 2 times column 2. When we multiply that, these 2 numbers must be the same. You can't do it out of order. If you do it out of order, you might not get the same thing. It's important that you put, in order for this to work, that you put the reflection matrix first. Okay? So let's say I have the coordinate matrix, or the coordinates A, B, C here, and I want to reflect it in the x-axis. But I don't have any graph paper. I want to be able to know where those coordinates are going to be. Matrices are a great way to do this. Okay? First, I need to know my x-axis reflection matrix, which is 1, 0, 0, negative 1. Now, you're going to find these matrices, because all the zeros, make multiplying super easy. We're going to multiply that times my coordinate matrix. My coordinate matrix is A, B, C. A is at 2, negative 1. B is at 6, 5. And C is at negative 3, 3. And now we're going to find out where A primed, B primed, and C primed are going to be. Reminder, how do we multiply matrices? We take row 1 times column 1. So 1 times 2 is 2, and 0 times negative 1, that's going to go away, 0. 1 times 2 is 2. Row 1 times column 2. 1 times 6 is 6. 0 times 5 is 0. So we get 6. Row 1 times column 3. 1 times negative 3 is negative 3. Plus 0 is negative 3. Now to get row 2. 0, negative 1 times 2, negative 1. 0 times 2 is 0. Negative 1 times negative 1 is positive 1. 0 times 6, row 2 times column 2. 0 times 6 is 0. We get a negative 5. And what are we going to get for our final C primed? That's our first question. Okay. How about reflecting this polygon in the x-axis using matrices? Now, again, usually if we're given the picture, we wouldn't bother with matrices. It's a lot more work. But in this case, I just kind of want to do at least a little something here. Again, reflecting the x-axis, we're going to look it up. That's 1, 0, 0, negative 1. And then my coordinate matrix. Well, my coordinate matrix, I'll call this point A, is at negative 1, 1. Point B here is at negative 1, 1, 2, 3, 4, 5, 6, 7. And point C here is at 1, 2, 3, 4, 5, 1. So we do our multiplication. 1 times negative 1 plus 0 is negative 1. 1 times negative 1 plus 0 is negative 1. 1 times 5 plus 0 is 5. 0 times negative 1 is 0. Plus negative 1 times 1 is negative 1. Then we get a negative 7. And what's going to come last? Once again, final question. You should be noticing a pattern here, by the way, pretty easily. That's a lot. We'll see you in class.